Hello guys. In the last lecture we learned about heating, cooling and ventilation. In that we seen temperature rise time relation, that is heating and cooling cause of electrical machines. Today we will see the numerical on temperature rise time relation to get the better understanding of it. So let's start with the problem statement. First of all, read the problem statement carefully. The temperature rise of transformer is 25 degrees Celsius after 1 hour. The temperature and time is given, and 37.5 degrees Celsius after 2 hours. So we have two temperature values and two time values that are of starting from cold condition. Calculate its final steady temperature rise and heating time constant. If its temperature falls from final steady temperature to 40 degrees Celsius in 1.5 hours when disconnected, calculate its cooling time constant. The ambient temperature is 30 degrees Celsius. From overall, by reading this overall problem, we can go for one conclusion is that there are two conditions. First condition is nothing but under heating condition, and second one is a cooling condition. The first part I am reading firstly I am reading this first part, that is the temperature rise of transformer is 25 degrees Celsius after 1 hour. It means from cold condition the temperature within 1 hour time, the temperature is going to rise up to 25 degrees Celsius. And second value is nothing but for the 2 hours after cold condition, within 2 hour time, temperature rise of the transformer is nothing but 37.5 degrees Celsius. Here we have to calculate in the under heating condition, we have to calculate its final steady temperature rise and heating time constant. Let's see firstly under heating condition. In the last lecture we seen the equation of heating condition as theta is equal to theta m 1 minus e raised to minus t upon tau h. In that, just putting the given values, that are 25 degrees Celsius for 1 hour and 37.5 degrees Celsius for 2 hours. Because of that two values we will get two separate equations. That first equation is nothing but by putting the value 25 degrees Celsius on left hand side, that is temperature rise 25 is equals to theta m 1 into 1 minus e raised to, I am putting here time 1 hour, that is e raised to minus 1 upon tau h. This is equation number 1. And second equation also you will get as on left hand side by just putting the temperature rise 37.5 is equals to theta m. On right hand side 1 minus e raised to 2. 2 is nothing but that for 2 hours from cold condition. There is nothing but equation 2. By taking the ratio of this equation 2 and 1, just simplifying, we have to calculate the theta m and tau h. By taking the ratio we can cancelize the theta m, and just by simplifying it, doing adjustment for numerator, in the numerator, that is a square minus b square. In the numerator part 1 minus e raised to minus 2 upon tau h, just I am adjusting for a square minus b square, so that I can write here a square minus b square is equals to a plus b into a minus b. So on the left hand side, by taking the ratio you will get 1.5, and on right hand side just we can say here a plus b and a minus b in the numerator. So I can calculate 1 minus e raised to minus 1 upon tau h from the numerator and the denominator. Finally you will get 1.5 is equals to 1 plus e raised to minus 1 upon tau h. So on the left hand side, by simplifying 0.5 is equal to e raised to minus 1 upon tau h, just adjust for with the logarithmic terms and you can calculate the tau h. Finally you will get the tau h is equals to 1.44 hour, that is nothing but heating time constant. So remaining is of from the first part, that is under heating condition, theta m we have to calculate. Just inserting this value tau h into the equation 1 or equation 2, any one of them. So just I am putting here that tau h, value of tau h into the equation 1. By putting this you will get 25 is equals to theta m into bracket 1 minus e raised to minus 1 upon 1.44. On left hand side the temperature as it is 25, and on right hand side just putting the value of tau h, and time remains same as 1 hour. So 25 is equals to theta m into bracket 1 minus 0.5. 0.5 is nothing but the value of e raised to minus 1 upon 1.44. So finally you will get that theta is equals to 50 degrees Celsius. This is about the first condition. Let's say about the second condition. Actually, in the second condition, in the problem statement given that the temperature falls from the final steady temperature rise to 40 degrees Celsius. So in the first part, we calculated the steady temperature, a final steady temperature rise, that is 50 degrees Celsius. So you can say that the temperature is falling from 50 degrees Celsius to 40 degrees Celsius within 1.5 hour time. It is also given as ambient temperature 30 degrees Celsius. But finally falls down temperature is nothing but 40 degrees Celsius and ambient temperature is 30 degrees Celsius. So temperature difference there may be there appears. So 40 minus 30, that is nothing but 10 degrees Celsius above ambient temperature. So we know that the cooling condition equations as theta is equals to theta I e raised to minus t upon tau c. Tau c is nothing but the cooling time constant, t is nothing but the time. So just putting the values on the left hand side, that is temperature difference 10 degrees Celsius is equal to theta is nothing but final steady temperature, that is 50 degrees Celsius, and temperature from 50 degrees Celsius falls from 50 degrees Celsius to 40 degrees Celsius within 1.5 hour. So putting a time t is equals to 1.5. Tau c we have to calculate here. So by adjusting this, taking the 50 degrees Celsius on left hand side, so 10 divided by 50, you will get the 0.2 is equal to exponential term as it is. Take the logarithmic relation with the exponential term, so you will get log of 0.2 to the base e is equal to minus 1.5 upon tau c. So finally you can calculate the tau c is equals to 0.932 hour. This is nothing but cooling time constant. So finally you will get the overall temperature as under heating condition. The final steady temperature rise is theta m is equals to 50 degrees Celsius, and tau h is equals to 1.44 hour. Under cooling condition, the cooling time constant is tau c 0.932. Thank you very much to listening to me. Thank you.